In this video, we'll look at molar ratios. So the coefficients in a balanced equation tell us the mole ratios of reactants and products. Here's a fictional chemical reaction. We have 2A plus 3B makes C and 2D. So what this means is 2 moles of A, that's what the 2 in front means, react with 3 moles of B to form 1 mole of C and 2 moles of D. So these numbers in front, these are the coefficients, and they tell us the mole ratios of the reactants on the left side and the products on the right side. However, in the majority of chemical reactions, we usually have a reactant that is limiting and a reactant in excess. I have a separate video that covers limiting reactants, so in this video I'll focus on molar ratios. So here we have a real chemical reaction. We have calcium carbonate reacting with hydrochloric acid to form calcium chloride, water, and carbon dioxide. Now this equation is balanced. According to the balanced equation, 1 mole of calcium carbonate, if there's no number there, you assume it's a 1. That reacts with 2 moles of hydrochloric acid, and that forms 1 mole of calcium chloride, 1 mole of water, and 1 mole of carbon dioxide. So let's try an example. Assuming that HCl is in excess, so we have plenty of HCl, that makes calcium carbonate the limiting reactant. So what amount in moles of H2O can be produced from 0.667 moles of calcium carbonate? So we need to look at the ratio of calcium carbonate to water. So the ratio is 1 mole of calcium carbonate to 1 mole of water. So it's a 1-to-1 ratio. So therefore, if we have 0.667 moles of calcium carbonate, we will produce 0.667 moles of water because of this 1-to-1 ratio. Let's try another example. This time, assuming that calcium carbonate is in excess, which means that HCl is the limiting reactant, what amount in moles of CO2 can be produced from 1.15 moles of HCl? So we need to look at the ratio again. So the ratio of HCl to CO2 is 2-to-1. So we have 2 moles of HCl to 1 mole of CO2. So therefore, if we have 1.15 moles of HCl, we will produce half as much CO2 because of this 2-to-1 ratio. So therefore, we divide 1.15 by 2 to give us 0.575 moles of CO2. Let's have a look at one more example. Here we have aluminium reacting with hydrogen bromide to form aluminium bromide and hydrogen gas. So our first example, assuming that hydrogen bromide is in excess, which means that aluminium is the limiting reactant, what amount in moles of H2 can be produced from 3.64 moles of aluminium? So we look at the ratio, and the ratio of aluminium to hydrogen gas is a 2-to-3 ratio. Now if it makes it easier, you can simplify this ratio to 1-to-1.5. So therefore 3.64 moles of aluminium will produce, now because it's a 2-to-3 or a 1-to-1.5, you can just multiply this number of moles by 1.5. So therefore it's 3/2 or 1.5 times 3.64 equals 5.46 moles of hydrogen gas. And our final question, according to the same conditions, that means the hydrogen bromide is in excess, what amount in moles of aluminium bromide can be produced? So we look at the ratio of aluminium to aluminium bromide, and we can see it's a 2-to-2 ratio, and you can simplify that to 1-to-1. So therefore 3.64 moles of aluminium will produce the same amount, that's 3.64 moles of aluminium bromide.